Hello smart mathematicians, let's do question 4a. In the diagram alongside, f of x is equal to 5 over x minus p plus q. We can see f of x here, which is a hyperbola, and g of x is equal to log of x to base 3. Okay, are drawn. You can see the graph here, the logarithmic graph g of x. And then x is equal to 2. X is equal to 2, the vertical line is an asymptote of f of x. Remember, a hyperbola has two asymptotes, a vertical asymptote and a horizontal asymptote. And then y is equal to 1, passes through c, right, and is an asymptote for f of x, horizontal asymptote for f of x. If h of x is equal to x plus t is an axis of symmetry of f of x, then determine the value of t. Right now, we have to understand the axis of symmetry for a hyperbolic function or for a hyperbola. Right, there are two of them. There's one that passes through the arms of what? Of the hyperbola, or intersects the arms of the hyperbola. So it will pass through the point where the asymptotes meet. So this will be the line like this. It passes through, or it casts the arms of what? Of the hyperbola. Right, as you can see here, this one here is what? Is an increasing graph. As you can see here, this is an increasing graph, meaning that it is a positive gradient. There are two of them, isn't it? One of them, the gradient is positive 1. The other one, the gradient is negative 1. So this one, the gradient is positive 1. So we can write it in the form y is equal to x plus c. And then here it means this is the one we're looking for, because here the gradient is positive 1. Okay, now the other one, like this, for this parabola, it is in between. So we have two axes of symmetry, one which casts the arms of the hyperbola, and the other one which is in between the arms of the hyperbola. So this one is a negative gradient, and the gradient is negative 1. So just those two. Just know that there's one with a gradient of 1, there's another one with a gradient of negative 1. And then they pass through the point where the asymptotes meet. Let's come back to our question. If h of x is equal to x plus t is an axis of symmetry for f of x, then determine the value of t. So it means we are just interested on this one. So we have h of x is equal to x plus t. So h of x is our y. So we have this point here where the axis of symmetry passes. So our y is 1. So the gradient is 1 here. So we just substitute our x, which is 2, and then plus t. Okay. And then we transpose our 2 to the left hand side, becomes 1 minus 2. What is 1 minus 2? Is negative 1 is equal to t. So t is equal to negative 1.